See guys, yes, you asking some questions, Santosh. Please ask your doubts.
Yeah, I ask question here. Right now, HBS is the online process. Why we use the PIG and EVO? Because they are the offline processes.
Yes, MapReduce program, Hive Pig are for offline analysis, and
Yeah,
HBase is online analysis, isn't
yeah,
it? So obviously,
yeah,
base language is different. It's like a query language, but not like SQL, isn't it?
yeah,
So most of the
yeah.
analysis, offline analysis is happening. After that, online analysis will do that. Depends on the client requirement, isn't it? But right now, the client has a already existing database. Suppose when the client has existing database, so we can write that is a very big data. We can take it to the HDFS. Then we can analyze with what?
Yeah,
MapReduce program, okay, or Hive
yeah.
or Pig, isn't it?
Okay,
But HBase is the
yes,
online
fine.
analysis. That means we are connecting the application UI, okay,
Okay,
server, okay, database.
yeah,
So these three combination, right? So obviously here what HBase is there in the backend, right? I told you right,
yeah,
Facebook
okay,
application, eBay, all these working with this architecture.
yeah,
One of mine. So when you open Facebook.com, when you enter the username password, you're getting the home page within the seconds, isn't it? Why? Because
yeah,
HDFS is going to read the big data from HDFS, right? In
yeah,
HDFS, not
correct.
only your the account, right? There is a millions, billions of accounts in HDFS. So obviously, when you enter the username password in the front page of the web page, and the record is going to verify that through the HBase, right? And HBase verify that
Yeah,
only where username equal to Santosh, where the password equal to XYZ. Only that record is
yeah,
only verifying that right HBase. Got it now? So this is online analysis. Understand now? So when you do
yeah,
the normal analysis, right, directly you can run on the HDFS, right, without any application. MapReduce program Hive is completely for offline analysis. What do you find?
oh, yeah. I understand. It's a it's a static databases. We use the almost like Eve, Ive and PIG. Yeah, is it good for static databases?
Sorry.
For existing database means is the static one. Yeah.
Yes, SQL database I told you, right? SQL, MySQL, DB2, Sybase, all these are right static databases, and
Yeah.
dynamic things are servers, isn't it?
Yeah, dynamic servers.
Got a point, guys? Yes.
Okay.
Babu, any questions?
Yeah, understand.
Babu, any questions?
No, right now.
See that now. Before going to discuss the Hadoop framework, yesterday I told you, right? HDFS, MapReduce, Hive, Pico, Scopo, Flume, HBase, isn't it? And Uji and Zookeeper. This is the entire all the components of the Hadoop framework. And first, before going to discuss the HDFS, first we need to know that Hadoop software versions. Okay, Hadoop software versions. So first of all, Apache given us this software actually. Apache is a company. If you want to check that every day software updation, anything happened, so there is a website link is there, apache.org website. We can find that any new release is coming from Apache, right? So Apache given the first starting days Hadoop software. So the version is Hadoop 1.x. That means 1.02 right up to it came for that Hadoop 1.02 Hadoop 1.8. Okay, I told you right here this Hadoop 1.x this engine is called inside Hadoop 1 software is the MapReduce version 1, and after that now latest version I told you right Hadoop 2 that is 2.x starting from the 2.02 right 2.8, right? So all these versions which will contain the what MRV2 engine which add yeah. Okay, so these are the Hadoop software versions. Please note down. All of you guys need to know it. Write the notes always. When you're writing the notes, it's very good for you to follow the subject.
Yeah.
So Hadoop software versions. So there's the things. So Hadoop 1 MRE1 engine, Hadoop 2 onwards, that is MRE2 Yarn, isn't it? So Yarn full form here at another resource negotiator. Yarn is only working with MRV2 guys, not with MRE1, okay?
Yeah.
Okay?
Yeah.
Let's see that now. So all of you note all these points, okay?
Yeah, I did.
Yes. So for Hadoop software, there is a platform provider that is Cloudera. So Hadoop Software's right platform provider. So we are calling here distributors. They'll ask you normally interviews which distributor you working that for big data projects. Okay, so distributor means who are the providing the platform for the big data projects. I mean for Hadoop software. Hadoop is just software, guys. So right for Hadoop software projects, so there is a predefined platform providers out there that are called distributors. So very popular distributor for Hadoop software platform, that is a Cloudera, isn't it? So the Cloudera giving that the platform for the Hadoop software, that is called CDH. Okay, most of the industry using that Hadoop software platform, that is the Cloudera. Most of the companies using Cloudera. The CDH, the platform name you are calling CDH. CDH full form Cloudera distributed for Hadoop.
Yeah.
Most of the industry using this Cloudera distributor for analyzing the big data with a very user-friendly platform, guys. It's just simply plug and play, which I already sent you email yesterday, right? Right? That is a simple plug and play, guys. Very user-friendly platform provider in the world for big data projects, especially Hadoop softwares. The platform provider is the distributor is one of the Cloudera. Okay. See that in the Cloudera versions, the platform versions of the Hadoop software, the starting is CDH3. CDH full format, what I told you, Cloudera distributed for Hadoop 3. Okay. CDH3 version in this platform, in this distributor version, which is integrated with Work Engine, World Engine, with all the component Hadoop frameworks, Scoop, Flume, Hive, Pig, everything is integrated with what? MRV1 engine. Mapd is version 1. Okay. From CDH4 onwards, okay, it is integrated with the what? Latest engine, MRV2 Yarn, isn't it? Good of mind, guys. From CDH4 5 onwards, with MRV2 engine, Yarn, and it added in this CDH5 Spark also added, isn't it now? So these are the distributors. Now CDH 5.2 came and CDH 5.7 came, CDH 5.8. See that whatever distributor you're using, guys, doesn't matter. Everything is a user friendly, guys. Here there is no API changes. Whatever version of distributor working for your project, guys, there is no change of API, isn't it? Only right user friendly difference, isn't it? If you work with the old version distributor and compare with the CDH4, CDH4 is very user friendly. Compare with the CDH4, CDH5 is very user friendly. That is the only difference. The distributor versions difference only user friendly, guys, not API difference, isn't it, guys?
Yeah.
Hope you understand now. Okay.
Yeah.
Next one more for a Cloudera competitor, one more distributor working. Some companies using Hadoop software platform. Some companies using this Artnow distributor. So this is HDP. Okay. Most of the industry using Cloudera, guys. And second priority, Hortonworks. Both are open source, guys. Cloudera, all these open source, just simple plug and play, guys, isn't it? And Hortonworks, HDP, Hortonworks distributed platform, and both are Cloudera and Hortonworks open sources, and very expensive and costly license version Mapper. This is also distributed for Hadoop software platform providers, but most of the industry is using Cloudera. So we are going to work with the Cloudera distributor as the Hadoop software platform with the components of the Hadoop framework. So very user friendly Cloudera, and Hortonworks also same thing. And Mapper is license version, guys, expensive, but that's why most of the industry using very friendly environment of the platform provider for Hadoop software, that is the Cloudera. Okay, guys, understand now? Now done. So already given to you the old version of the Cloudera. This platform I given, right? This Cloudera distributor I version. This version I sent you email yesterday. All of you downloaded, right? The same thing. Now get one point, guys. After that, I'll send you latest version CD4 also. Any Cloudera distributor working, buddy, only user friendly difference between the versions, not API. Okay. Okay, guys. Hold on. First point, guys. So Hadoop software versions I told you, which is given by Apache. Cloudera is a platform provider for the Hadoop software, isn't it, guys? Love understand now. Apache is a software provider, guys. Just Apache company is just a software provider, and Cloudera is a Hadoop software platform provider, isn't it? Understood now, guys?
Yeah.
So most of the industries projects, big data analysis, they are using the distributor, that is a Cloudera. Most of the companies using Cloudera. Second priority, Harden works. Sorry, now whatever distributor is selected doesn't matter, right, buddy, for your big data projects platform. Finally, we need to get the required data for analysis. Understood, guys? Next, so we've seen that Cloudera distributors. If you want to download any distributor, this website is there. Cloudera company. It's in this website. Whatever version now you wanted for our software platform, you can download from this website. Already given to you, right? Stage 3. And just if you want to download the only software, this is the website, isn't it? Right. Now still now we discuss, right, introduction of all the Hadoop framework components and distributor for the Hadoop software platform. Now I am telling you we are going to discuss first Hadoop 1, the world software, Hadoop software. Still some 30 to 40% companies using still old version, but we need to know how to what is the right HDFS with MRV1 engine, right? Got it now, right?
Yeah.
So when distributing file system working with the MRV1, that is Hadoop 1. When Hadoop 2 is nothing but when the distributing file system working with what? MRV2 yarn, guys. So these are the two architectures available to analyze the big data in the world in Hadoop framework, guys, isn't it? Now see that
Yeah.
first we need to discuss HDFS, guys, right? So I told you HDFS means what? Using for storage, guys. HDFS only purpose storage. How the people is preparing with the HDFS? Set of nodes. I told you HDFS full form, Hadoop Distributed File System. It is a set of preparation of the nodes, buddy, preparing by administrator with a set of nodes. What is a node, buddy? So node we can call what? We can call disk. We can call also machine. Understand now? Don't confuse. The node is only for what? Storing the data. Okay. So data stored in the node, how, guys? The data stored in the nodes in the form of blocks. Remember, very important point. So data stored into nodes, right? But data stored in the nodes in the form of blocks. So default block size 64 MB, okay, and default replication HDFS 3, guys. Distributing file system is nothing but set of nodes. The data preparation, right? Obviously, every project will start with the kickoff meeting, guys, in big data projects. Administrators to decide to prepare the HDFS either cloud or with your own premises, isn't it? The distributing file system is nothing but set of nodes. So we need to buy the storage from any infrastructure provider if you don't have premises in your company. It depends on the most of the industries using nowadays cloud only, isn't it? So to prepare the HDFS, we need a set of nodes, right? Data stored in the nodes in the form of blocks, guys. The block size 64 MB and default replication 3, guys. Isn't it, guys? Allow me get my point.
Yeah.
So distributing file system preparation, whatever infrastructure you wanted. See that I'm putting the heading here, HDFS infrastructure technology. Okay, HDFS infrastructure technology, guys. The companies, they don't have a premise. Most of the industry, they will not take risks to prepare the HDFS in their own organization, guys. Most of the industries using the cloud services. But anyway, whatever infrastructure need to prepare the HDFS, guys, I'm writing the words here. Cluster. Okay. Yesterday we seen the diagram, right? You remember? I'll show you again. Don't worry. Cluster inside data center inside racks inside nodes. Right now, to prepare the distributing file system, whatever in premises we need it, right? Cluster nothing but what, guys? Set of data centers. Data center inside what is that? Set of what is that, guys? Data center inside what? Set of racks. Racks inside what? Isn't it? Set of nodes. The data is stored in the nodes, right? So what is there inside the nodes? Your data in the form of blocks. Data stored in the nodes, right? Set of blocks. What point, guys? To prepare distributing file system, we need a cluster, data centers, racks, nodes. Obviously, so with all these terms, we will prepare the distributing file system, isn't it, guys? Suppose if you prepare the distributing file system with 100 nodes, obviously we can call what? 100 nodes cluster. This is the way to pronounce, guys. If you work with the one node cluster, you can say one node cluster. If you work in the one node, you can say one node cluster. If you're working with the 10 nodes, you can say 10 node cluster, isn't it? If you're working with the 50 nodes cluster, isn't it? How many nodes are there? Obviously, the way you definitely in first interview question at every Hadoop developer facing that, can you tell me what is your HDFS size? Immediately say that number of nodes should be highlighted. If you work with 100 nodes, you can say 100 node cluster, guys. If you work with the 4 nodes, you can say 4 node cluster. Understand my point? This is the way to pronounce that. I don't bother number of racks, I don't bother data center. The mainly nodes, your data stored in the nodes. Allocate my point, guys. So to prepare a distributing file system, we need a cluster, data center, racks, nodes, guys. So this is the way to prepare the file system. Got it now? Our target data stored in the nodes in the form of blocks. Understood, guys? Okay. Allow me to note on these points. We are discussing only HDFS here. In this HDFS, I'm not including MapReduce, guys. First, we need to understand complete HDFS. Then we'll go to MapReduce later. Okay. Please ask me any questions. Any doubts?
No, fine. Yeah.
Okay, understood, guys.
Yeah.
Yes, Babu, any questions?
Yeah, understood.
So now we'll see diagram. Yesterday I showed you the diagram, the distributing file system diagram. How it's that?
Venkat, one question here. Here default size is a 64 MB means
Default block
it's
size. The block size 64 MB. Whatever file you are writing to HDFS, every file is
yeah.
to break into blocks, and the blocks storing into the different nodes with the replication.
Okay.
I will tell you. Don't worry.
Got it.
First we'll see that. Then we'll go to the next point. Don't worry. Right. See the distributing file system. Okay. See the node 1, node 2, node n, and node 1, node 2, n number of nodes. The racks inside nodes, rack 2 nodes, rack n node, n number of racks here. The set of racks inside the data center. Okay, data center inside, racks, data center's main cluster is there, isn't it? So this is distributing file system, guys. What are the nodes in the racks, right? All the nodes are slaves. Remember, the node which is in the node rack is called slaves, isn't it? The nodes are called data nodes, or you can call slaves here. But here I told you, right, to manage all these slaves, there is a one machine is there, master machine on the top of the rack. That is a master machine. I told you that is also name node, isn't it? So to prepare HDFS, guys, we need two types of nodes. Remember, when you want to prepare the distributing file system, administrator will take the two types of machines, isn't it? Distributing file system preparing by the two types of nodes, but racks inside that is a data node. First listen, two types of nodes in prepare HDFS. One is master machine, isn't it? Master node. This is called name node, and this is also called meta node, guys. Understand now? Those are the things. And after that, and what is that? Next slave. This is slave node. This slave node, what is that? Data node. Isn't it right? Racks inside what? Slaves, right? But here mention the point, important point. Master node is always for the cluster is only one. How many slaves doesn't matter. Okay, master machine is only one per cluster, guys. The point, only one per cluster. But slaves, how many, guys? Data nodes will be multiple, guys. Understand now, guys? Data nodes will be multiple, but master machine is only one per cluster. So here you can ask me a question. So in this diagram, where is the master machine? The master machine is not inside the rack, guys. Master machine is always outside the rack, isn't it? So obviously, outside the rack means master machine and the rack inside all the slaves, isn't it, guys? Here, nodes are using to only store the data, guys. I said, but to manage all these slaves, I mentioned there is a master machine that is called name node. The name node managing all these slaves. And you can ask me a question. Here, every slave, every node will report to the master machine. That is called heartbeat. In case any slave will not report to master, that means slave is dead, isn't it? The master managing the slaves. Here, every slave will give the communication information to the master. In case if any slave will not report to master machine, that means node is dead, isn't it, guys? The point you need to guess it. Okay, will I get my point? So here, out of the rack, you can put the master machine, and all the slave will give the report to master machine every 3 seconds, guys. Every slave need to report to master machine every 3 seconds. 3 seconds. Continuously, all the nodes running parallelly, right? Understand my point? That is a distributing file system here. Will I get my point? Yes, Babu.
Yeah, I understand. Means if we write every 3 seconds means is replicated big data, right? Large data is stored.
Yeah, when you putting any file into HDFS, master machine what it will do? It break the file into blocks, and master machine place the blocks into different nodes with replication, isn't it? See my screen.
Oh,
When the developer run the write operation, right? Suppose your file name is RAM and your file says 1 GB, isn't it? So you want to put this file into HDFS. What the name node will do? Here master machine is a configurable with what? It's configured with what? Block size 64 MB, isn't it? Isn't it? Is a configured with what? Replication 3, guys. All of you understand now? So obviously tell
yeah.
me, when you want to put this 1 GB file into HDFS, how many blocks will get it? Tell me. Name node to break the 1 GB file into how many blocks now? Tell me. Calculate it and tell me. If you want to put any file in HDFS, name node break the file into blocks, and name node place all the blocks into different nodes with replication. Now tell me. Now name node is going to break this 1 GB file into how many blocks?
Obviously 156, 160.
How many?
Sorry.
My file says 1 GB, guys. So now my block says 64 MB, replication 3. So name node break
Yeah.
this file into how many blocks, guys?
400,
Come on, yeah.
1000.
Only you have a calculator, you have a mobile phone with you, and you have a front of the laptop is everything is with you.
156.
How many blocks will get it?
We get 156 blocks,
So how
but
can
the replicator is 3 means
your file says 1
156.
GB, right? How can you say 156 blocks, buddy?
So
156 blocks,
sorry.
buddy. 1 GB file, buddy. The file I want to put into HDFS, the name node break the file into blocks now.
16 blocks, yeah.
In HDFS, every request passing through the name node. So you are going to put the file 1 GB file. So name node break the file into blocks. How many blocks will get it,
60,
guys?
60, 16, 1 6.
Yes, 16 blocks. 1 GB
Yeah,
equal to 16 blocks will get it. So 16
Yeah.
blocks with replication how many? Replication 3, right?
3.
We multiply with
Yeah.
replication 3. Totally how many blocks? Tell me. 48 blocks,
48.
right? The name node, every request passing through the name node in HDFS, right? Name node is a configurable with the block size and replication. So obviously, when the developer want to put any file into HDFS, first name node takes the request from the user, and name node break the file into blocks, and name node place all the blocks into different nodes with replication, isn't it? These 48 blocks are stored into the different nodes. So the 48 blocks means what, guys? The block 1, block 1, block 1, isn't it? Block 2, block 2, isn't it, guys? Block 2,
Yeah.
block 3, block 3, block 3, block 4, block 4, block 4, isn't it? Understand now? Like this,
Yeah,
so on. How many blocks? Block 16, isn't it? Block 16, isn't it? Block
Yes.
16. See that?
yeah,
So obviously, whenever if you want to put any file in HDFS, master machine name node, that means name node break the file into blocks, and name node placing the blocks into the different nodes. Why? Because master managing the slaves, guys, name node knows which node has a how much space, which node has a which file blocks. because name node is also called, I told you, meta node. So name node maintain the meta information of the every block information. Suppose this block 1 in the node 1, same copy in the node 8, isn't it? Suppose in case, isn't it? Node 8, and same copy maybe here node 4 maybe, isn't it? Understood now? Same copy is not storing
Yeah.
the same machine, it's storing to different node. That is the meaning of distributed. Whatever file you are storing in HDFS, the complete file is not storing the single machine in production. It distributing to different machines. Got it now? Understand now? Suppose here node 1 is a fail, guys. Obviously, data will be saved because same copy in the node 8, right? And node 4, isn't it? So data will be never losses. I told you yesterday, data availability is one of the very good important feature of the big data project using Hadoop software. Hadoop is high fault tolerance, guys. In case any slave is a fail, I don't bother about data loss because replication is there. Replication allows you without data loss. Understand my point, guys? All of you?
Yes.
So any
Yeah,
file
understand.
you are moving to HDFS, the name node break the file into blocks. Okay, the file when you want to write the data into HDFS, first in HDFS, I'm telling you HDFS. So name node taking the request from the user and name node fail the by break the file into blocks and it multiply with replication 3. Isn't it? Block size fixed, guys, 64 MB industry practice and replication is 3. People asking the question, Venkat, if I take in the replication 3, it will take a lot of storage. I need to buy the so much storage. Yes, compulsory you need to buy that in a production cluster. Isn't it? Administrator can customize the replication 3 or 2 or 1. Depends on that, isn't it? But in production cluster, replication will be 3. So it is a customizable, either 2 or 1, but not be 0. Replication is the fundamental of the big data analysis. Without replication, there is no big data analysis in the world. Isn't it, guys?
Yeah.
Otherwise, the got my point, guys. Do you understand? So distributing file system only for storage. Whatever file you move into HDFS, the master machine is going to be break the file into blocks. You can ask me question. Even the name node only configure with the block size and replication only. It is a configure with what? Meta information also maintain that. Remember, isn't it? The master machine maintain the metadata, right? So who will remember that? You are going to put the millions of file in HDFS. So we need to know that which node has a which file blocks. Who knows that? The name node. Understand my point? In HDFS, every request throwing going with the mapper going with a name node only. Isn't it, guys? So name node knows which
Yeah.
node has a which file block. Name node knows which node has a which how much data. Which node has a live. Name node knows everything. Isn't it, guys? Because there is a network connection guide, guys. The point here showing the diagram. Here, what are the racks inside nodes are there? Every slave is the network communication with the master machine. Isn't it? Master machine knows which node is live, which node is dead, and which node has how much space, which node has a how many, which block is there, which file block is there. Name node knows everything. So because the name node maintain the meta information of the entire right file information of the every file information of the meta information, the name node, isn't it? Name node no need to use storage. Name node always using RAM. Remember, where the name node maintain the meta storage, name node using RAM, guys. Here data node is the storage. Name node is no need of storage, right? Only name node is only always depending on the RAM only. Name node always need a RAM, but slave is a data node is using to store the data. Here we need a storage, guys. Remember, isn't it? Name node will not use the storage, but it maintain the only meta information in the RAM. Isn't it my point? What my point? People asking the question, Venkat, you
Yeah.
said name node is only for one cluster. In case if name node fails, obviously if name node fails, entire cluster will be down. It's a big risk for administrator to restart the cluster again. Isn't it, guys? So that's why in the production cluster, when the administrator of preparing the distributing file system, he will take the expensive hardware, high configuration system for the name node. Because this is a single point of failure, right? You have a slave, if you use expensive or inexpensive, doesn't matter. Even a slave fail, data will never lose it. What about point, guys? Understood now?
Yeah, understand.
So distributing file system separation with always with the two types of nodes. The master node, that is the name node we are calling, and slave, that is the main data node. So slaves always inside the racks, which are using to store the data in the form of blocks, isn't it? Suppose you put the 200 million tables in HDFS, you don't know that where is which table in which day, which node. Who knows? The master machine that I told you, name node. So in HDFS, if you want to run anything on HDFS, every request passing through the name node. I'm telling in HDFS, guys. Actually, request coming through the MapReduce, I told you. But here I'm explaining HDFS only. In HDFS, every request coming through the name node. In Hadoop, every request coming through the MapReduce engine. Isn't it, guys? Love it, good point.
Yeah, understand.
See that now? Yes, understood?
Yeah, understand. Yeah.
See the point here. So what I'm saying that whatever file you're moving to HDFS from the client source with running scoop or with running flume, right? So obviously what the name node will do, it break the file into blocks, isn't it? See that? The point here, use the blocks to store a file or a part of the file. That is a distributing file system, guys, which is going to break the file into blocks, and blocks are stored into the different nodes with the replication. Got a point, guys? Okay.
Yeah.
Yes.
All of you writing the points or not, guys?
Yeah, I'm writing it.
Tell me if you want.
Yeah, right.
I'll give the time to write the notes. Okay.
Yeah, right.
Okay.
Okay.
Okay, complete.
See that now. See that the point here. Your default blocks is 64 MB. I told you, and 128 is recommended. You can use either 64 MB or 120 MB, but most of the people in 64 MB or 120 MB. And people asking the question, can I take the block size less than 64 MB? If the administrator, suppose unfortunately if we take the block size less than 64 MB, so meta information will be increasing, and it is a burden for the name node, guys, isn't it? So beyond the scenes, normally in operating system block size maximum KBs only. So here distributing file system, it is a 64 MB, nothing but it is equal to number of OS blocks. So 64 MB is nothing but is not a small, guys. It's a big. In production cluster, guys, remember, if you've seen any file greater than 64 MB size, that file is a big. If you've seen any file less than 64 MB file, that is a small file. Remember, isn't it now? There is no purpose to analyze the less than 64 MB files in the production. Isn't it now? Got a point? The purpose
Yeah.
you are using Hadoop software to analyze the big data, the file will be maybe in GBs, maybe in terabytes. Isn't it? So that we need to analyze in the production always. Got a point? So if you take the you administrator take the blocks or less than blocks say 64 MB, it will be a burden for the name node, isn't it? Got a point? See that previously we discussed that here 1 GB RAM, so 1 GB file, it break into 16 blocks and got the 48 blocks. So why? Because
Yeah.
blocks is 64 MB. If you take 32 MB blocks, what happening? It will increase in more blocks, right? Isn't it?
It's
And
right.
more meta information increasing for name node, and meta information if increasing it is burden for name node, isn't it? So industry
Yeah.
practice block size 64 MB is the best practice, or 128 MB is recommended, isn't it?
Yes, correct.
Yeah.
And see the point here fits well with the replication to provide the fault tolerance. Why blocks means, buddy, availability. When you putting any file, guys, the complete file will not be in the singlest node, right? It breaking the data into blocks, all the blocks stored into different nodes. Your complete file information not in the single node, isn't it? So the distributing means your parts data storing the different nodes, the parts wise, isn't it? So here the Hadoop is a fault tolerance. I told you it's a high replication is there, high availability, data availability is scalable. Everything is there in this distributing file system, guys, to analyze the big data. See the advantage of blocks. Fixed size, easy to calculate how many fit on the disk. Suppose I decide that my node size 1 TB. My data node size 1 TB. Can you tell me how many blocks will fit it in 1 TB nodes? Tell me, guys, my node size is 1 TB. See, in 1 TB node, how many blocks can fit it?
15,000. Hello?
16,384.
Okay.
Hello.
How many?
16,384.
Yes, 1 TB. It can fit 16,000 blocks approximately. So
Yeah.
1 TB is 1 TB node. If taken that, obviously 16,000 blocks will fit it. But 16,000 blocks belongs to the one file? No, it belongs to the multiple file blocks, isn't it?
Yeah.
Correct. Suppose my node size 1 TB, but I'm going to move the file 2 TB file. I'm going to move to the HDFS. My node size 1 TB, but I'm going to move the 2 TB file into HDFS. Can I face any error?
No.
Yes, Santosh?
Yeah, explain again. Yeah, question one more time.
My file says 2 terabyte.
Yeah,
My node says 1 terabyte. When I'm going to put this 2 terabyte file into HDFS, will I face any error?
I think so. It's
How
not.
many nodes we have?
This is multi-node cluster. Okay, tell me.
It will store up to 1 TB. I think so.
Huh?
It will store up to 1 TB. After that, it
I'm telling
shows
that my
error.
cluster is a multi-node cluster. I'm going to put the 2 terabyte file into the HDFS. Can I face error or not?
Because
Multi
it's.
nodes we
Sorry,
didn't get, I think so.
we'll get the error.
I think so. We
That
will
is
get error.
depending on confirmation, I mean configuration.
We'll get error, yes or not, guys?
I think so. We will get error.
How can you say you will get error, buddy? 2 terabyte file is not storing the single node, right?
Okay,
Gaurav,
different nodes.
data is
Yeah,
going to breaking, right? The complete file is not storing the single machine, right? What I'm telling,
yeah,
right? Every file in HDFS is going to break into blocks. Whatever 2 terabyte, 100 terabyte doesn't matter. The file is going to break into blocks, isn't it? We seen very clearly. See that 1 GB 16 blocks with storing the different nodes with the replication, right? The 16 blocks not storing the single machine, right?
yeah,
So whatever file size doesn't matter. When I'm working with a multi-node cluster, when I'm going to put the whatever file, my file size is greater than node size doesn't matter because the complete file is not storing the single machine, right? Got a point?
yeah. Understand.
That's my point, guys. So, so easy to calculate with the how many bit on the disk. A file can be larger than in the single disk. Yes, whatever HDFS we're using, that your file may be greater than node size, but don't worry about that. It's breaking that any HDF any if you're putting any file in HDFS, the file is going to break into blocks, and blocks are stored in different nodes with replication, isn't it? Yes, guys.
Yeah,
Yeah.
So here, see, a file or a chunk of the file is a smaller than block size, only needed space used. Your example 420 MB file is there, and here 4 blocks are there, and see the last block 36 MB. Your block size taken the 120 MB, the developer want to put the 420 MB file in HDFS, it got the 4 blocks, but the last block how much? 36 MB. But still space in the block, right? The master machine will not waste the storage like this. It can put the another file block in the same block, isn't it now?
yeah.
Name node will not waste the storage. See that here 420 MB file is completely stored in it, but last block still space is there. Still how much space in the last block, tell me?
128 MB.
Still how much space is there, guys? What, yeah, I got 128 minus 36, buddy. How much time, buddy?
9.
Come on, guys. What happened, guys?
92. Yeah.
92 నా ఈ పక్కన ఎవరో చెప్తున్నారు కదా ఆన్సర్.
Hello.
ఎస్ ఎస్.
So 1.
How much, yeah? 90, yeah? 92 MB, yeah?
92.
92 MB?
Yeah.
92 MB space is there still. So name node will not waste the storage like this. So name node can place the another file block into the. So distributing file system is prepared by administrator with the set of nodes. Obviously, administrator will decide the how much node size will be there, what is the block size will be there, and what is the replication is there. But whatever file you are putting to HDFS, name node break the file into blocks. It places the blocks into different nodes. In case your complete block is not full here, still 92 MB is there. Name node can place the another file block in this space. So name node will not waste the storage, isn't it?
Yeah.
That is the point. Distributing file system always using to prepare by administrator, right? With the proper calculation. Every project will start with the kickoff meeting. In the kickoff meeting, Hadoop administrator, the person who is experienced of networking guy, he will decide number of nodes to prepare the file system. Isn't it? Each node size, how much, what is the block size, what is the replication value, isn't it? How many nodes we need to use? He will decide that. How he will decide? Based on the how much database giving by client. Based on the client database size, we'll decide how many nodes we needed to prepare the file system, isn't it? Example, when you doing partitioning your hard disk, right? When you installing OS in your machine, suppose without partitioning of your hard disk, there is no purpose to install the OS, isn't it? The same thing here. If you want to analyze the big data, we need to prepare HDFS, then we need to do analysis, isn't it?
Yeah.
What of mine? Okay.
Yeah.
So whatever file you move into HDFS, the file name will not waste the storage. It can place the another file block like this if anything happened like this, isn't it? Understood now?
Yeah.
Yes, Babu, understood?
Yeah, understand.
Yeah, here my question is that here I'm showing the one more diagram here. Please tell me here. Please don't give the any blind answer. Please concentration on this diagram and tell me the. My question is that what is the replication value here?
Based on this diagram too.
Lot of disturbance is coming from your side, guys. What is the replication value here in this diagram?
2, yeah. It is the 2 replications.
Actual blocks how many?
Actual blocks is a 6 blocks completely.
Actual blocks.
2 blocks.
Huh?
2 and 3 blocks.
No, actual 6.
You are not
6, right?
your friend who is sitting beside of you. You are listening your friend voice. Okay, I'm listening your friend voice, Santosh.
No. Just I'm sitting in the room, yeah.
What is actually here?
Actual nodes are 6.
Actual
Replica
blocks
is
are 6, sir. How can you say 6 blocks, buddy? Actual
It's a
blocks
3
are
blocks.
actual blocks are 3 with the replication
3.
6, right?
Yeah, 2 replications.
Actual blocks 3 only, right? The file has only 3 blocks, but it replication with what? 6 blocks. Replication is 2, right? What of mine?
yeah.
That's my point. Here, node 1 is a fail. Suppose my data saved because same block 1 in the node 2 and block 2 in the same block copy in the node 3. So, in case here any node is a fail, data will not losses. Data will be safe. So, replication is the fundamental now. Understood now? So, whatever data you are putting into HDFS, data will be stored into different nodes with replication. Replication is the fundamental. Without replication, there is no big data analysis in the world, isn't it?
Yeah.
Got it now?
Yeah, I
Okay.
understand.
What about guys? So replication, how is important for the big data projects? So it is allows you without data loss. Even if you node fail, data will not lose. So whatever data you are moving to HDFS, your file is going to be break into blocks and all blocks stored into different nodes with the replication.
Okay.
What of mine? Okay.
I understand.
Okay.
Now see this. So please note down this diagram. When the developer run the scoop or flume or anything or whatever, obviously every project will start what? First, once HDFS is ready, developer will move the files to the HDFS from the client database. Isn't it? Obviously, whatever you running with a scoop or flume, in HDFS, name node will take request from you. Actually, request coming through the MapReduce, but we are discussing HDFS here. Okay? Right? So, name node, every request coming through the name node here. Isn't it now? Here in this diagram, guys, name node in the rack. Please don't take this diagram as it is. Name node can put in the outside the rack. In your notes, you're writing the diagram. Suppose you can put the name node outside the racks and see the diagram. See, guys, here how many blocks of the file? My actual file. How many blocks of the file here actually?
It's a 12 blocks, yeah.
12 blocks, sir.
In the file, we have the 3 blocks.
12 blocks in. What is the brother? What is the my question? What is the saying your answer, buddy? Please concentration on my question. How many blocks of the file here? What is the actual blocks here?
3 blocks.
3 blocks, isn't it? Name node break the file. The file name is file1. Your file1 name file is breaking by name node into blocks. It break the 3 blocks. Now name node multiply with the replication with the 3. Totally how many blocks? Totally how many?
It's a nine blocks.
See that now. Name node places the block 1 in the rack 1 of the node 2. Same copy stored in the rack 2 of the node 1. Isn't it? Same copy
Yeah.
stored in the rack 2 of the node 2. See that? The data is distributing like this. Your file complete data is not in the node 1. Your complete file information. It is distributing. That's why speed
Yeah.
analysis will be very fast when you working with the distributing, because we are not working with a single machine in production. We are working with a multiple machine production cluster, isn't it? So still remaining blocks how many? Still have,
Remaining blocks is a 9 blocks there.
huh?
8 blocks there remaining. It's a 2 blocks remaining. We have the 8 nodes remaining.
Oh, come. I'm asking you question, but again you're very speed, Santosh. What is my question? I'm asking you. Still, how many remaining blocks to
It's
put
a
it
2 blocks.
to? What, Santosh?
We
Please
have the 3 blocks data in the file. Yeah.
take the time and tell me answer correctly. Whatever coming in your mouth, you're saying the simply very wrong answers. My question is there still how many remaining blocks are there to put in HDFS? Yes, Babu.
Two
Yeah, we need
two
to
blocks.
write other 2 blocks.
Yes.
The
How
replica
many
is 3.
blocks I'm telling you? Total how many blocks remaining?
2 blocks and 6 replications.
It's replication now. What
Two
happened?
blocks.
We
Govinda.
need to write 2 blocks in the HDFS.
What, buddy? I'm telling you again. See that name node break the files into block and it multiply with the replication 9. It already put into 3 blocks. Still remaining blocks how many?
6.
6
We have the
blocks.
two,
Yeah.
two, 2 blocks and 6.
Blocks.
Each
Yeah.
block has the 3
Blocks.
replications.
6 blocks are there, isn't it?
Yeah.
The point I'm not asking you, oh, 2 blocks remaining. I'm asking total remaining blocks how many? Isn't it?
6.
6 remaining 6 are there, isn't it? Now see that the complete file written to HDFS. See that now. The name
Yeah.
node plays the file blocks like this. Wherever space in the racks nodes, it put that. Name node knows in which rack which node has a space. Name node knows which rack which node has which file blocks. Because name node maintain the metadata. Isn't it now? So this is the way internally happening in that distributing file system, right? This is completely distributing what happening inside internally in hardware disks. This is happen when you put the files into HDFS, isn't it? You're moving one file or millions of files at the same, doesn't matter. Name node break all the files into blocks. It put the all blocks into different nodes with replication, and name node maintain the meta information of the every block of the information. Got it now?
Yeah.
Yeah.
Please note down this diagram clearly. So, explain the HDFS architecture means, please explain the only HDFS only. How can you say, yes, when the developer run that, any scoop or flume in HDFS name node taking the request, and the name node break the files into blocks, and name node place blocks into different nodes with the replication, then all nodes will be the acknowledged to name node. You see that whatever nodes inside the rack, every slave will report to name node. That is called heartbeat, I told you. What is the communication happening between the slave and master is called heartbeat. In case if any slave will not report to name node, that means node is dead. Isn't it, guys?
Yeah.
Yes.
Please note down diagram clearly.
Uh, Venkat, I have a doubt.
Yeah, please.
Actually, if we means name node having the metadata,
Mm-hmm.
any node maintain the metadata of name node? Means another node is available for the
slave
maintaining
information.
the metadata?
Name node maintain every slave information, guys. Okay.
Okay.
What are the blocks in the node 1? What are the blocks in the node 2? What are the blocks in node 8? Name node knows because name node is master, isn't it? Got a point. I have 10 laptops, right? 9 laptops are slave. One machine is the master, right? Got a point. Master maintain the slaves, isn't it?
Master, yeah.
Okay. Yeah. Actually, I have one doubt. Like we maintain the replica of data, and also maybe a chance to maintain a replica of name node.
Sorry. Yeah, name node maintain the every information, not only actual block information, but the replication information also, right? Isn't it? Yeah,
Yes.
node 1 is the node 2, right? Same copy in the node 2, node 1 of the rack 2, isn't it? Yes. Got it now. Not only actual blocks, I'm telling you, isn't it? Every block, isn't it? Got a point?
Yeah.
Previously, which I mentioned
Yes.
here, previously my file says 1 GB. I mentioned that 48 blocks in meta information maintained by name node. 48 blocks in which nodes? 48 blocks are where are located name node nodes, isn't it? Got a point? We don't want
Yeah.
to remember no one can remember. The only machine is the master machine, which is a maintaining in the RAM. It holds the complete meta information of the every node, every block, every file information, isn't it? Maintain the uniquely, isn't it? Without any repeatedly. Got my point?
Yeah.
Understand now? So in this point here, in this HDFS, only mainly drawback, name node is only one. The drawback of this distributing file system, which is working with the MRV1, I'm repeating again, guys. We are discussing HDFS, which is working with MRV1, isn't it?
Okay.
Distributing file system, which is working with the MRV1, isn't it? So this distributing file system, which is
Yeah.
working with the MRV1, I explained that when HDFS working with the MRV1. So I'm telling you here, name node is only one per cluster. If name node fails, entire cluster is down, isn't it? It's a
Okay.
big risk for administrator
Yeah.
to restart the cluster again. Got a point? That's why administrator, when it's working with the MRV1 engine, name node will be taken by administrator with a high configuration system, expensive hardware. Because single point of failure, right? If it is fail, unfortunately, it is complete gone, isn't it? It's a big risk, no doubt about that, isn't it? So slaves, if you take
Yeah.
expensive or inexpensive, it doesn't matter. But name node master mesh should be expensive, high confidence system is there in production. If in case fails, it's a big risk, no doubt about that. Okay, understand now?
Yeah.
Yeah,
Yeah.
all of you understand now. So wherever HDFS is running in the world, so we will take simply the name node IP address. Suppose your HDFS running in the cloud, right? Your cloud provider, they will give the HDFS URL like this: localhost colon port number. Wherever HDFS is running in the world, guys, we will access the HDFS to your machines. I don't bother HDFS where it's running, but I need to know name node IP address, isn't it?
Okay.
HDFS UI, or
Yeah.
you can say, isn't it? Name node URL, isn't it? Yes, guys.
Yes.
So wherever HDFS is running in the world, the only IP address will be configured to our machines, isn't it now? Suppose your company working
Yeah.
for a big data analysis for Walmart, obviously your company has no premises to prepare that much of big data storage file system. You are going to depend on the cloud services, and they will give that IP address to you. But in the place of local host in the production, we'll get the IP address. But in your own machine, we'll get the local host, isn't it?
Okay.
That's my point, guys.
Yeah.
Got it now? So when you open this URL, we can see the complete HDFS summary. How many nodes are live? How many nodes are dead? We can see everything like this, isn't it now? See that I will show you in my system.